In mechanical and process engineering, for drinking water supply, in the chemical and petrochemical industry, for industrial furnaces, for power plants, in the food industry as well as in various other industrial processes, customized industrial blowers provide a fresh breeze. They reliably supply fresh air around the clock, improve water quality, or control heat treatment. Designing and producing industrial blowers for the global market, for capital goods, that's the core business of Pillar Industrial Fans for more than 100 years. But how is a fan made? At the beginning, there is, simply spoken, a huge pile of material. Depending on product, size and application, this could be as little as 50 kilograms or up to 40 metric tons. Because the vast majority of fans in production are based on custom orders. So let's start. There's lasering, drilling, welding, bending, balancing, blasting, painting, assembling, checking, testing, packing, and shipping. Done. Too fast? Okay, let's slow it down. Everything starts with the receiving of goods. All received materials will be unloaded, forwarded, unpacked, and checked. Sounds easy. It is, as long as professionals do the work. All purchased and produced parts have to be thoroughly checked during the incoming goods inspection. Is the part in compliance with the shipping note and the purchase order? Are the dimensions and thicknesses correct? Arcing testing and surface roughness testing is also carried out. Only with these inspections can we ensure that all necessary materials are ready for production with the correct quantity and quality. But how does the material get into the production? With a push of a button, just like magic. All parts needed for a particular order will be provided by the fully automated Cardex storage system within a wink of an eye. These 6 computer-controlled shuttle systems, standing 9 meters tall, allow fast access to up to 70,000 different items. Each shuttle can take up to 30 metric tons. Thus, less paper, less storage space, less errors, and less forklift rides. All parts are available. Let's go! In prefabrication, the big steel plates are checked, measured, and tagged. If everything is okay, they will be carefully lifted onto the laser cutter machine. This high-precision robot cuts the up to 15 millimeter thick steel plates with an accuracy of 1/10 of a millimeter and leaves as less residue as possible. For example, an impeller. That goes fast. Due to the size of the end product, the laser cutting for stainless steel impellers takes from 4 to 30 minutes. For pieces with a thickness of 12 millimeters, the laser cutting machine cuts up to 20 impellers a day. The operator of the laser cutter has to be highly skilled, has to master cutting speed, materials and material properties, as well as the settings for the machine itself. He has to know all of this by heart. Now we're spinning, no matter if it is a shaft, a hub, or a gigantic impeller. Pillar Industrial Fans has outstanding machinery available to do all the various machining steps for little, medium-sized, and large workpieces. From CNC lathes to milling machines to the high-end boring bar. Stainless steel shafts and hubs are machined with a state-of-the-art cyclic lathe. Especially large workpieces, for example impellers, are machined with a surface lathe. In this case, it drills cylindric and tapered bolt holes with an accuracy of less than 1/100th of a millimeter. With additional machining centers, welding seams for impeller backplates, hubs, or blades are prepared. Special mills are machining the groove of a shaft. In Bay 10, the casings of the industrial blowers are produced. It is also high-precision work. Step by step, the base casings are tack welded, which means they are only welded at particular spots. It is very important that the so-called stiffeners are accurately located and the angle between them is correct. After that, the workpieces will be inseparable, connected with a special welding procedure called MIG. It fits 100%. At the same time, various add-on parts like discharge nozzle or inspection opening are welded to the casing. The latter is extremely important for repairs, cleaning, and maintenance of the blower. The stainless steel casing is moved to the desired location with the 2-trolley bridge crane. Welding residue and grooves are removed in order to create a clean corrosion-resistant surface. Also, the sharp edges on the casing will be deburred, thus preventing injuries. Finally, the workpiece comes to the quality gate. At this checkpoint, the dimensions are measured. Welding-induced deviations are recorded so that they can be considered in the following production processes. A lot of know-how and experience is required for the manufacturing of the impeller, especially when the blade is formed and an accurate design-conform curvature is needed. A handcrafted masterpiece made by a pro. Everything is man-made. The machine just follows orders. All pieces of the impeller are prepared, assembled, and ultimately welded. With the new turntable, impellers up to 2,700 millimeters in diameter and a maximum weight of 2.5 metric tons can be produced. The impeller can be moved in every possible position, and the welder always has a perfect angle to work with. What looks like a nice pink coloration is in reality a very important test, the dye penetration test. The inspector checks whether or not the material and especially the seams are free of impurities and fissures. The pink penetration liquid can creep into any little opening in the material. After applying the liquid, it takes about a half an hour to dry out. Meanwhile, another test is about to begin. Safety first. Positive material identification is the next test hurdle in front of the workpiece. Is the chemical composition of the material correct? The spectroscopic analysis helps to determine the content of the examined alloys. This method uses the property of any chemical element to emit a unique light spectrum. The computer embedded in the test device accurately measures and identifies the elements. Wrong materials or alloys at pillar? Impossible. The next step is to wash off the penetration liquid. A special developer solution makes crack and fissures visible. They will be marked and reworked. With the portable 3D pickup head, shapes and positions are measured. That is to say, smoothness, lengths, angles, radii, and parallelism. There are still more tests to go, like final inspections and pressure tests, so that the calculated design pressure of particular goods can be guaranteed. For that, there is an inspection stamp. Trust is good. Control is better. After this extensive material check, the state-of-the-art boring bar has its stage appearance. The SpeedRAM 1000 is capable of performing multiple machining jobs. With 10 independent controllable axes, casings, base frames, bearing houses, nozzles, and naturally impellers can be precisely milled, drilled, bored and threaded. The outstanding capacity of the boring bar is its huge variety of machining tasks, along with the number of axes and its precision. The impeller gets up to speed quickly. It is balanced at 500 to 1000 RPM. This speed is comparable to the rotation of the crankshaft in an idling car motor. In order to have a rotating body move smoothly around its axis, the mass has to be equally distributed. To achieve this goal, small masses have to be either added or removed. In Pillar's workshop, the so-called balancing is tested with a specially designed rig, and the impeller is dynamically balanced in two planes. In case the impeller is unbalanced, the worker adds weight by welding a small steel plate onto the impeller. Thus, the vibration limits are surely met and bearing damages can be avoided. Smashing! All big components for a blower, first of all, casing and impeller, are set and done. That's a blast in two senses. The surfaces are evenly blasted with stainless steel beads. Ultimately, a flat passivized surface has to be created. In doing this, the parts are corrosion protected, which is an important aspect since some of the blowers are used in the sensitive world of food production. Painting of the blowers provides further corrosion protection. After cleaning, covering, applying a primer coating, drying, applying the final coating, and drying again, it gets serious. Is the paint thickness correct? Is it below the target or above? The thickness testing of the final coating has to be within the given tolerances. The paint thickness determines whether or not the blower is properly corrosion protected. Commencing countdown. All parts and components for the assembly of the blower are allocated in a designated area. All parts are put together to form a single unit. The final assembly of a pillar blower is done using assembly drawings, test and inspection plans, and parts lists. The impeller is mounted to the shaft using a so-called hydraulic fit. Now, everything depends on the accurate reading of the set values and sound and concentrated work, because every pillar blower is different. That alone shows that the assembly time can vary from 90 minutes up to 50 hours. In any case, pillar blowers are a customized product. Once the blower is in the testing area, electronic technicians check and inspect every single one of them and put them through their paces. The standard tests are visual inspection, mechanical test, run hot gas test, bearing temperature test, and performance test. Especially the vibration test reveals unbalance and prevents the fans from early bearing damages. Power and volume flow are thoroughly checked. And the temperature measurement knows the limits and tolerances, thus avoiding long-term bearing damages as well. A lot of wind for nothing? No way. Material and production quality of pillar fans are no coincidence. Before a blower hits the road to its final destination, quality assurance staff members carry out the final inspection, starting from dimensional checks to visual checks and ending with thickness testing. They make sure that all spares are aboard and the blower is free of damages and is complete and therefore faultless. Only after this thorough procedure, the blowers get their nameplates. In any case, the blower needs its bag with the certificate of conformity and an operating manual. The blower is now ready for shipping. Finally, the blower has the go for dispatch. Double checking of packing lists, tagging, taking pictures, packaging, and so forth. All final preparations are running at full speed. Then the fan is, as a figure of speech, grabbed by its throat. A crane lifts the blower carefully onto the truck, and in the meantime, the customer has prepared his construction site as well. Maybe the fan will be air freighted to Jakarta or Melbourne. Maybe it will reach Great Britain by ocean freight, and its final destination is Manchester, or it will be trucked to Murmansk in Russia. There is hardly any country where no pillar blower is operating. The numbers are growing steadily year by year. They run and run and run, sometimes for more than 20 years. Overall, the global player Pillar Industrial Fans makes some 700 blowers a year. Now, we all have to take a deep breath, don't we?